10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80, décollage. La propulsion est nominale. Acquisition de la télémesure par la station de Saint-Jean-du-Maroni. Les paramètres à bord sont normaux. Trajectoire nominale. Pilotage calme, propulsion nominale. Tous les paramètres à bord sont normaux. Pilotage calme. Tous les paramètres à bord sont normaux. Trajectoire nominale, pilotage calme. Séparation P80.
Samuel, oh my God, I am
Allumage
very
Z23.
While the launch, look, we can see the P80 separation in live from the cameras. It's wow.
This is incredible. I am very impressed to have witnessed this launch for the first time in my life. It's crazy how fast it went.
Yeah. And so far everything is nominal, so it's very good. So in the Zefiro 23 has ignited, so started the second stage phase. So in a few seconds, he will have finished his job and separate from the launchers, and then the third stage will continue to continue the mission.
So now we are waiting for the next announcement, and this follows the basic principle. When it comes to a space launch, you've got to shed as much weight as possible and as fast as possible, right?
Yes, indeed. The principle is to get rid of the useless mass. As you heard, we separate the first stage, then we soon separate the second one. And the basics is when an engine has finished burning and consumed its propellant, we just separate it. If we keep it on board, we would bring useless mass into space, and this useless mass is also costly in terms of propellant. So that's why we split a rocket into different stages to be able to get rid of the mass as we go, when it's no longer necessary.
So within 3 minutes, our launcher has gone from 138 tons to 21. That means it's shed some 85% of its mass.
Yes, it's huge, and at the same time, we've gone from 0 to 3.6 kilometers per second in this time. So it's in 3 minutes. So it's crazy. So we have confirmation of the Zefiro 23 separation, and we should have soon the Zefiro 9 ignition. So we will just wait a few seconds for the
Z9 confirmé. Séparation quoi?
It's just confirmed.
It's confirmed, yes. So the fairing is off now. Why? Does it mean we don't need to protect our satellite anymore?
In fact, the fairing protects the satellites when the launcher goes through the atmosphere. Because clearly when we pass through the atmosphere, it generates quite a significant environment due to the aerodynamic friction. So, for instance, it generates vibration or heat for the satellites. Once we are out of the atmosphere, these aerodynamic loads have been completely reduced. So we can just get rid of the fairing. Once again, the principle is to avoid dragging a mass that is not useful anymore.
And now looking at our 3D rendering of events, the animation takes into account the position of the sun and its reflection on our launcher. What we're looking at is an animation of what is expected to unfold up in space at this very moment. So this is as close as we can get to real-time imagery.
Yes, this 3D animation does not show the real-time behavior of the launcher, but it shows the predicted behavior of the launcher as it is expected. So it includes, of course, the trajectory, the velocity, the altitude, the ground track, etc., the different stages separation, but also the launcher maneuvers. It really shows the launcher orientation through time, including the orientation with respect to the Earth or to the Sun.
And tonight's is a sun-synchronous mission. What does that mean?
Yes, sun-synchronous orbit means that the satellites are flying over the Earth region always with the same sun orientation, so always at the same local time. It means you can easily compare pictures taken at the same time, but for different days. This is why it's often used for Earth observation satellites.
But it also means we have to launch at a precise time and have no launch window.
Yes, indeed, because we target a precise time for the orbit. So given the mission duration from the takeoff to the injection on the orbit, then we need to launch at a precise time to respect the final local time of the orbit.
And now, Samuel, we are waiting for another announcement, which is the Zefiro separation, the Zefiro 9.
Yeah, we are close to the end of the Zefiro 9 burning, so we call it queue de poussée, so the last part of the burn. So far, as we hear from the DDO, all the parameters on board are nominal, and the control of the launcher is very calm. So this is really good news. It means everything is on track and fine. We just had the confirmation. For the Zefiro 9 separation. Yeah.
They just confirmed the separation of the third stage. So can you please explain to us what does it mean?
So it means we have finished the 3 successive significant acceleration flight phases, and now the launcher is flying very fast at 7.5 kilometers per second. So just to compare, it's 30 times faster than a commercial aircraft. So that's huge. And we are flying roughly at 200 kilometer altitude. And as for the previous stages, the Zefiro 9 is separated and the fall down is located in the ocean.
And now we are pursuing with the waiting for the Galileo's signal and the Bermuda acquisition visibility like, where everything is normal right now.
Acquisition de la télémesure par la station de Bermude.
Flight path tonight. Yeah.
So we are just acquiring acquisition from Bermuda. So now we are in contact with this station.
And Vega's flight path tonight takes it northwards across the Atlantic over the North Pole and back down, and along its journey, tracking stations along its path pick up the launcher signal. Who's in charge of this, Samuel?
So yeah, it's a CVI team, so it means Control Visuel Immédiat, or real-time monitoring, and they receive major flight parameters from the launcher all along the flight to monitor what's happening on board. It's a bit like the doctor checking the health monitoring parameters to verify that everything is fine on board. So the team in charge is located in Gallio on La Montagne des Pères, close to Kourou. It's possible, as you said, thanks to several ground tracking stations used for this mission, which are located along the ground track of the launcher. So first in French Guiana, then on Bermuda Island, and then Canada and Australia.
And so another step coming up is the confirmation of the first ignition.
Perfect timing, yes. Eleonore. Congratulations.
Thank you.
So we had the confirmation of the first AVOM ignition.
Yes, absolutely. What does this mean?
It means that this is the last stage of the launcher. It will deliver our first customers to their final destination with a very good precision. So the first